Next, we're going to cover what we should be looking for when we have opportunities for inspections and preventive maintenance of DC motors with them down and locked out. Here are some things we should be doing during field day opportunity with our DC motors. You should be measuring useful slot depth. Be sure the slot depth is greater than 20 thousandths. Anything below 20 thousandths, we should schedule that motor off. Ensure proper brush grade and quantity. Restore brush integrity. The length and the shunts are all in good condition. Ensure new brushes slide freely in the holders. Make sure that there's proper and consistent spring pressure. Ensure reliable electrical connections. Remove all carbon and contamination that result in a path that tracks to ground, such as the banding on the commutator and the brush arm insulators. Remove all scale anywhere and everywhere, whether the scale is in the brush path, on the riser, anywhere. Take that scale off. We can use Scotch-Brite materials to remove it. Identify bar-to-bar burning. Make sure that you don't see any banding or burning. Record and measure and track the armature ground wall resistance. Anything less than 1 megohm, we should put it on a list and watch it and see if it continues to degrade. If it does, that motor should be scheduled off. If you cannot clean the motor well enough to bring the meg up and it continues to degrade, that motor should be removed before it fails. Areas to concentrate cleaning on for a low armature meg result include the banding that's installed on the end of the commutator. We should also note and record the condition of the commutator surface. During these critical inspections, we should have a final QC step where someone is responsible for signing off that the work has been performed correctly. They should be looking at certain things and signing off before covers go on. They should make sure that the slot depth is not below 20 thousandths. Confirm all short brushes have been replaced. Confirm proper brush quantity based on the paperwork. Make sure to confirm the proper spring pressure and that all springs are properly latched. Too many times brushes and brush springs get set in and then not properly latched, and so they pop out. Review the cleanliness inside the motor. All the insulators need to be very well cleaned and make sure all materials have been removed from the motor. If after cleaning the armature, the ground wall resistance is still less than 1 megohm, we should at least alert the area and make sure that we're watching that motor. Review the paperwork for completeness. Review accuracy of the paperwork and then sign off as QC inspectors. Here's an example of measuring the slot depth when the caliper is inserted into the slot. And we take different readings along. If it's usually we take, if for a 4-pole machine, we'll take 4 readings in each brush path around the commutator. And this slot depth, I believe, is around 51 thousandths. Here are some areas to look at. Around this banding in the edge of the commutator bars, there could be some burning. This type burning at the banding next to the commutator will start out like a little horseshoe shape and it'll grow. If not found and corrected, it will only continue to grow, and this will be the result. If you're getting moisture and water in the motor, you'll see areas where the unpainted surfaces are rusted. If that's happening, you should contact the area and see if there's water intrusion in the air duct. If so, here's some white substance that was also entering the motor over here. And this could be coming through the air supply or through covers. During inspection, look for field poles that look overheated. This motor should have been removed and field windings investigated and possibly rewound. Here's a field pole winding that has become darkened, and here's another one. Field pole windings have been overheated during this operation, and here's cracking due to overheating. This is a clean brush arm insulator. Here's another one that needs more cleaning, and here's one that got damaged because of lack of cleaning. It's very important that we keep them clean. If we don't, they'll lead to a ground and a fault in the motor. A typical distribution system that supplies a line of DC drives is either an open ground system or high resistance ground system. And this allows us to run with one ground, but not two. If we develop a ground current will flow, but we don't fault or fail. We continue to run. However, if we develop a second ground, we'll trip. And then we'll fail. It doesn't have to be the same motor. We could actually have a second ground inside the same system, but anywhere on the system. And here's the result of a second ground. Let's talk about threading. Under normal conditions, some copper is removed from the commutator and vaporized. Sometimes the copper does not completely vaporize, and instead it transfers into the brush face. This work-hardened small particles become hardened, and they're harder than the copper commutator surface. They then cut into the commutator, making fine threads. Operating at low current densities decreases copper vaporization, which can increase threading. Com scale and light spring pressures cause brushes to lift and arc, which lead to copper impregnating the brush and result in threading. Corrective action is to clean up the air, ensure you have adequate spring pressure, and brush is operating at the right current density.